Yeah, so if I try to understand Roger Penrose's conformal cyclic cosmology, then with the relativistic slide rule, then this seems to be how it would go underneath. So I've squished down my analytical coordinates and rotated them, and then I've graphed that one, but the rest of it is just an image to save. I've graphed that one, which is mass, and that one, which is Planck's reduced constant divided by the mass. But this one here, the inverse of it divided by 4 gives the gravitational constant, which is not a constant. And so the Big Bang is right at the beginning down the bottom here, and then the mass sort of like takes this gravitational force into itself, and so the gravitational force drops and drops and drops, and then when the mass starts to decay away, the gravitational force increases again, and eventually it gets to extremely strong value, and that's the low entropy gravity that Penrose talks about. And according to the relativistic slide rule, that's when all the particles are cut from the the same field, and they've just got different radii. That's what gives them their different masses, is the different radii alone. So you've got proton and electron, and that's an error bond. And if I was to calculate the mass of an error bond, I find that its radius has to be about 10 kilometers. So it's a massive particle with a tiny mass, the Planck mass. And what about its lifetime? According to Penrose, it has a half-life, and I calculate it to be about that, and when the universe gets to a radius of about that, then you get to the half-life, and this is the point where they just start decaying, and so they've got to be all decay away, and so most of the mass in the universe is these error bonds, and eventually it all ends up in the black holes when in a black hole when B is the square root of 0.5, and then it just takes forever for them to evaporate away, and as they do, the gravitational force just gets stronger and stronger until it gets to the level of the strong force, at which point the particles are cut. And then according to Penrose, only photons can go across to the next universe because they're massless. But I've got this and so that looks like the high entropy curve of the cosmic microwave background. I just graphed it. That's mass alone. That's the reduced Planck's constant divided by the mass. So what happens is your B value it starts off 1, and then like your Big Bang, and then you can see that red dot just coming down as the gravity drops, and eventually you get to where we are now, so somewhere around there, and it's just going to keep progressing, and eventually all the error bonds are going to end up in black holes, and the black holes are all going to evaporate away, and then you go head up, and then that all goes to infinity, and then another Big Bang there, and all happens again.